Dear students, welcome to my YouTube channel. In this lesson, we will do some examples of Fourier series. Okay. First question is, okay, we can write f of x equals to, okay, we know the Euler's formula for a0, an, and bn. That is, a0 equals to, here the function is x in between 0 to 2 pi. So the integration becomes x dx, okay, equals to, we get a0 equals to 2 pi. And an is, for this kind of integration, we use the UV formula for integration. That is, here V1 is integration of V dx, V2 is integration of V1 dx, V3 is integration of V2 dx, and so on. U dash is du by dx, U double dash is d square u by dx square, and so on. Okay. So, for this kind of integration, that is when there is a product of two functions, we use the UV formula. Okay. For this, take xhu and cos nxhv. Okay. So the integration becomes 1 by pi. First term is uv1, u is x, and v1 is integration of v dx, v is cos nx. So integration of cos nx is sin nx by n. And the second term is minus u dash v2, and the u dash is derivative of x, that is 1. Here v1 is sin nx by n. So integration of sin nx by n is, okay. And the third term is u double dash v3. U double dash is derivative of u dash is 1. So derivative of 1 is 0. And the next term becomes 0. Okay. This is the integration of x cos nx, and the limit is 0 to 2 pi. Okay. Equals to, you can see the first term becomes 0 after putting the upper limit and lower limit. You can check it by yourself. And the second term becomes cos 2n pi is 1. So 1 by n square minus cos 0 is 1. So 1 by n square. Okay. This becomes 0. So an is 0. Okay. Bn is, for this kind of integration, we use the UV formula. Okay. For this, take xhu and sin nxhd. Okay. So the integration becomes, and the next term becomes 0. This is the integration of x sin nx, and the limit is 0 to 2 pi. Here you can see the second term becomes 0 after putting the upper limit and lower limit. You can check it by yourself. So the first term becomes equals to cos 2 n pi is 1, so minus 2 by n. Okay. We found a0 equals to 2 pi, an equals to 0 and bn equals to 2 by n. Now we put these values in the expression of the function. Okay, that is here the an is 0, so all the coefficient of cosine function becomes 0. Okay, so the series becomes a0 by 2 plus okay, a0 is 2 pi, so 2 pi by 2 plus b1 is minus 2 by 1, b2 is minus 2 by 2 and b3 is minus 2 by 3 and so on. Take minus 2 common, we get this is the Fourier series expansion of the function. Okay. Next question is let f of x equals to x plus x square equals to, we know the Euler's formula for a0, that is a0 equals to, here the function is x plus x square. Okay, so the integration becomes and the Euler's formula for an is for this kind of integration we use the UV formula. Okay, that is for this take x plus x square hu and cos nx h v. Okay, equals to 1 by pi here you can see the term containing sine function becomes 0 after putting the upper limit and lower limit. You can check it by yourself. So only second term exists. For the upper limit it becomes, and for the lower limit it becomes cos of minus n pi is cos n pi, so it becomes cos n pi. We can write cos n pi equals to minus 1 power n, because the value of cos n pi is either 1 or minus 1 depending upon the value of n. That is, cos n pi is 1 when n is even and cos n pi is minus 1 when n is odd. Okay. Euler formula for Bn is for this kind of integration, we use the UV formula. For this, take x plus x square hu and sin nx h v. Okay, so the integration becomes take cos n pi by n common. From the Euler's formula, we got now use these values in the Fourier series expansion of the function, that is, a0 is 2 pi square by 3, a1 is minus 4 by 1 square, a2 is 4 by 2 square. Like this, put all values of an and bn, that is the coefficient of cosine function and sine function respectively. Okay. Now take 4 common from the cosine series. We get take minus 2 common from the sine series. We get this is the Fourier series expression of the function. Okay. The function f of x is valid for all the values of x in between minus pi and pi, but it is not valid at the end points, that is at minus pi and pi. So at the end points, the value of the function, that is f of pi equals to now substitute x by pi in the Fourier series expression of the function. Okay. Here you can see the sine series becomes 0 for the values of x. So the series becomes for x equals to pi,